Okay, let's talk about transformations. That's when we change in position or size of a figure. We're mostly going to be looking at graphs. So the order of transformations is super important. You're always first going to do a horizontal translation, and last will always be your vertical translation. Alright, a translation of a graph is a linear transformation that slides the graph horizontally or vertically. Translation produces a congruent graph. Okay, starting left, we have a horizontal translation affects the x coordinates. So all horizontal will affect your x coordinates, whereas vertical translation affects your y coordinates. Alright, we get a horizontal translation when we add or subtract a constant inside the function. And we get a vertical translation when we add or subtract a constant outside the function. Okay, we're going to use the letters H and K for this. So H is horizontal, K is going to be our vertical. Alright, so notice the H is inside the function, so inside the parentheses. If we have x minus h, we're sliding right h units. With x plus h, we're sliding left h units. Alright, now this is probably the opposite of what you would expect. And the way I remember that is that the inside is inverse. So anything that's happening inside the function is going to have the inverse effect on the graph. Alright, so an example here would be y equals x minus 2. This will shift our graph, f of x minus 2. It'll shift our graph right 2 units. Now let's look at the vertical side. Notice the plus k and minus k are outside of the parentheses, outside the function. So if we add k on the outside, we're shifting up k units. If we're subtracting, we're shifting down k units. So exactly like you would expect. Plus is up, minus is down. Alright, so an example would be y equals f of x plus 6, we would shift our graph up 6 units. And this one is pretty easy to remember because if you think back to Algebra 1, where y equals mx plus b, remember that plus b, that was your y-intercept. So that's how much you would shift that line up or down. Okay, let's look at some practice. If we're given the function f of 1 equals negative 2. I think normally we would see f of x equals y. So in this case, if this was a point xy, our x would be 1, our y would be negative 2. So I'm going to start on the left, find f of x plus 3. The plus 3 is inside the function, so that means we're going horizontal, so left or right. It's plus 3, which would automatically make you think maybe right 3, but remember inside is inverse, so we're actually going to shift the graph left 3. So if we're starting with the point 1, negative 2, when I shift left, that only affects that x coordinate. So we're shifting left 3, so we'll be at negative 2, and the y value will stay negative 2. Okay, looking at this example on the right, y equals f of x minus 2. So it's outside the function, so it'll be a vertical transformation. And it's minus 2, so we're shifting the graph down 2. So if we start with the point 1, negative 2, and we're shifting it down 2, that will only affect our y. So our x stays 1, and our y goes from a -2 to a -4. Let's see what this looks like on a graph. So we're going to graph the function y equals, or f of x equals x squared. That's our quadratic parent function. So I'm going to graph that. And we see we have a parabola starting at the origin. Now, if you ever don't remember how to graph parent functions, don't stress, because you could always pick some points. Oops. -2, -1, 0, 1, 2. And then you would plug them into the function, which is x squared. So you have -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So that's where I got all of those points. Okay, now we're going to graph the new function. Y equals f of x minus 2 plus 1. So let's start by talking about the order. Remember, we're always going to do horizontal first, and then vertical last. So the horizontal transformation, if we have x minus 2, inside is inverse, so we'll be shifting right 2. And that plus 1 is outside the function, so it's our vertical shift, and plus 1 would say we're going up 1. So we're going to take each of those points, move it right 2, up 1. Starting at the origin, if we're starting at 0, 0, move it right 2, and then up 1. Okay, and then at that point 1, 1, let's move it right 2, up 1. -1, -1, right 2, up 1. 2, 4, right 2, up 1. And then -2, 4, right 2, up 1. And we get our resulting graph, which is still a parabola. It's still a quadratic function. We just shifted it on the graph right 2 and up.